Hello. In the following problem, we want to write the following system of equations as an augmented matrix. Then we want to use the Gauss-Jordan method of row operations to solve the system. We want to show all work and give the row operations performed. Okay, to begin with, we have 2x minus y equals 8, and we have negative 2x plus 3y equals negative 12. In order to solve this, or even to put it into the augmented matrix, we need to make sure that this is in standard form. Remember, for linear equations, you need all variables on one side and the coefficient on the other, or the constant term on the other. So these are in standard form, so that's good. What I'm going to do now is I'm going to start out with the augmented matrix. I'm going to call it matrix A, and I'm going to go with the coefficients 2, negative 1, 8, negative 2, 3, and negative 12. And I'm going to put a line right here that effectively separates the coefficient matrix from the equal vector. Now, what we want to do, because this is a 2 by 3 system, or a 2 by 3 matrix, we want to put this in the form of 1, 0a, 0, 1b. To get there, I need this first element here to become a 1. To get to a 1, I multiply by the reciprocal. The reciprocal of 2 is 1/2. So I'm going to multiply the first row by 1/2. And that's going to give me a new row 1. So matrix B is going to be a new matrix, but the bottom row is going to stay the same. The reason it stays the same is because I'm just multiplying the top row by a non-zero constant. So 2 times 1/2 is 1. Negative 1 times 1/2 is negative 1/2. And 8 times 1/2 is 4. Good. I've got the 1 here and the 1 here. Now I need to go to this 0, which means this negative 2 needs to become a 0. Now, to get to a 0, I use the opposite of whatever this is. The opposite of this is positive 2. I'm going to multiply by the other row, which is row 1, and add that to this row, which is row 2. And that's going to give me a new row 2. Remember, we always want the row that changes to be the last thing that you write down. So that's going to give me matrix C. The top row will not change because notice that it's just row 2 changing. So it's just 1, negative 1/2, 4. Now 2 times 1 is 2, plus this negative 2 is 0. And that's the reason we did this. 2 times negative 1/2 is negative 1. Negative 1 plus 3 is 2. 2 times 4 is 8. 8 plus negative 12 is negative 4. Good. Now what I need to do is I need to get this 2 to a 1. To get from a 2 to a 1, the question is, what do I do? Well, I multiply by the reciprocal. The reciprocal of 2 is 1. 1/2, sorry. And multiply that by row 2. And that's going to give you a new row 2. So it gives you a matrix D, which is 1, negative 1/2, 4, 0, 1, negative 2. Okay, we have one more operation to do here, and that is to change this negative 1/2 to a 0. And to get to a 0, I use the opposite. The opposite of negative 1/2 is 1/2. I multiply by the other row, which is row 2, and add this to this row, which is row 1. And that'll give me a new row 1. And that'll give me matrix E, And notice that for matrix E, the bottom row doesn't change. It's still 0, 1, negative 2. And then in the top row, 1/2 times 0 is 0, plus 1 is 1. 1/2 times 1 is 1/2, plus negative 1/2 is 0, which is what we wanted. 1/2 times negative 2 is negative 1. Negative 1 plus 4 is 3. And there you go. This is in the solution form. The only other thing we need to do now is write down the actual solution. The solution is an ordered pair because there are two variables, is equal to, in this case, x will be 3 and y will be negative 2. Excellent. Now, we want to be able to check ourselves. In fact, we want to be able to use the calculator to do this, period. Now, to do that, I'm going to take my calculator and I'm going to turn it on, clear anything I have on here, and then I'm going to go into matrix. That is second, which is in the x to the minus 1, which says matrix right there. I don't have anything in here right now, so I'm going to go over here twice to edit, and I'm going to edit matrix A. And matrix A is a 2 by 3 matrix, so 2 enter, 3 enter. Type in all of these elements from A. That gives me 2, negative 1, 8, negative 2, 3, and negative 12. Be sure to click enter after every one of them. Then you want to quit to the home screen. Now, to just check our answer, we can go to second matrix, go to math, and then just go up until you see RREF. That stands for reduced row echelon form. Go back into matrix and tell it to do it of matrix A, because if you don't tell it to do that of a matrix, it won't be able to do anything. Click enter, and you notice that it tells you your final matrix 1, 0, 3, 0, 1, negative 2. Good. However, let's just say you didn't realize that, and we went to math. Now notice that the first thing I do is I'm just multiplying a row. So I'm just going to multiply a row, that's star row. Click enter, and you tell it what you're multiplying by, in this case 1/2, comma, which matrix, which is matrix A in this case, comma, which row, 1, close parentheses, enter. Now you'll see that it uses decimals, so to get the fractional form, just click math, enter, enter. Now we want to store this, so I'm going to click STO, and then go back into matrix, and do it of matrix B. So go down 1 and click enter, and then enter one more time, and it's now in matrix B. Next, we want to do the 2R1 plus R2. Notice I'm multiplying and then adding. So go back into matrix, write 1, go up and still, well, I guess you don't have to go but once, star row plus. So click enter. What you're multiplying by, in this case, 2, comma, which matrix, which in this case is matrix B, enter, comma, which row you're multiplying by, 1, comma, and which row you're adding, 2, close parentheses. Now the reason I do it like this is you can just see it 2, 1, 2, 2, 1, 2, and telling it which matrix in between. There you go. Store that into the next matrix, in this case matrix C. Then do the next one, 1/2 row 2 gives you a new row 2. So matrix, write 1, star row because we're just multiplying. It's 1/2, matrix C, and row 2. Enter. Good. Store that into matrix D. Enter. Go back into matrix math. Star row plus this time. 1/2, 2, and 1 is what we're going to type in. So 1/2 matrix D 2, 1. Enter. And that's that final matrix. So there you go. That's how to do this by hand. That's how to do it using the calculator to check it using RREF, the reduced row echelon form. And that's how to do it the long way using this information out here.